Do you see me? I assume, yes, you can now see me and hear me. So we continue our course on verification of smart contracts on the Ethereum blockchain platform. And just to recall the basic context that I was asked by my colleagues to speak on this topic. And okay, so I started preparing a lecture, but then we realized that not everybody understands well what is, in general, what is the idea of formal verification. And similarly, blockchain is still rather new technology, so not everybody is good at it. So finally, we decided instead just of one maybe lecture to have this mini course, which will consist of two introductory lectures. The first one we had before. It was on general approach to verification of software, and you can find it on YouTube. And today we have the second introductory lecture. It will be on decentralized finance on Ethereum. And then once you get basic ideas of these two technologies, the third and final lecture will be devoted to exactly our kind of goal and topic of this course, how to apply formal methods, formal verification to smart contract on Ethereum. So let me share my slides. Okay, should work now. Presentation mode. So, okay, so today is 8th of April, 22nd, and I'm in Colombo, and today rain started, so we are switching from dry period to very rainy period. But anyway, we continue our lectures, and today I will speak on decentralized finance on Ethereum. Here is the plan for our course, our lecture today. I will start with some very basics of blockchain. Then I'll talk about smart contracts. Then about something which is called crypto, which is the idea of using tokens for different purposes, which is called cryptonomics, and the idea of ICO, and kind of we'll finalize it with the idea of a decentralized autonomous organization, which is called DAO. And finally, we'll speak about Solidity, which is programming language used on Ethereum platform to write smart contracts. And this is kind of the first choice if you'd like to code something, to program something in this area. So first about blockchain basics. Here I assume that you know nothing or almost nothing about blockchain. That usually when someone starts explaining this idea, we start with this very simple example. So consider you have some people who, okay, buy something and just a part of some economy. So you exchange some money. So doesn't matter which currency is it. It could be dollars, euros, pounds, or whatever. So I use just abstract token symbol. So, for example, Alice on the left sends some money to Carol. Bob sends another amount to Carol. Carol sends something to Elizabeth, etc., etc. Basically, this is what happens every day in our life, because each of us participates regularly in all these economic transactions. But if you try to think how it really works, realize that someone has to keep track of all these transactions. And usually it is kind of the central bank of your country, which keeps tracking of all the transactions just to make sure that everything goes okay and okay, just the system works. So this table usually exists in some currently electronic form, which exactly describes what happened with the money. So you see A, I use some random numbers to indicate that A is Alice's account, B is Bob's account, C is account of Carol, D for David and Elizabeth. And you see that first we had some transaction from this account to another account, you have these fields, then surely you need to have some kind of timestamp to indicate when this transaction happened, and then amount. And then we go line by line just to have this information stored in just one table. So this table is in fact very useful and very important for every finance, because from time to time some people got in some trouble, something did not happen, someone sent money but the money did not appear on the other account, or someone can try to just maybe say that, okay, this did not happen, I did not send any money, or what were I asking about, etc. So you need someone, kind of the third party, usually it's kind of a trusted third party, who keeps this information. And once you got some kind of unclear situation, you can both go to central bank or to some similar organization to check what really happened. And this will be kind of the base for the decision. And the basic idea of full blockchain is try to avoid the third party. This is the whole story is about. And the solution is rather straightforward. So instead of designing someone kind of to be a central bank, we can distribute this information over the network, so that this table could be stored on everyone's personal computer. So Bob has the list of all transactions, Carol has the list of all transactions, David, etc., etc. Then once this is done, you don't really need no other bank or third party, because everyone has his or her own copy of the whole list of transactions. Then, okay, then the problem is solved. The only technical problem is to make sure that all the copies are identical. This is it's called the consensus problem. So, because it may happen that Bob sends something to Carol, and then he updates his table, but Carol did not receive this money, so she did not put this line into her table. So you see, although the idea seems to be quite simple and easy, you immediately will face some technical problem, how to make this really well replicated, and how to establish consensus without referring to third party. And that problem was solved exactly by what we call now blockchain. And this is actually the formal definition, which I like. That's why I suggest to read it just word by word. So a distributed ledger is, in fact, a database that is shared and synchronized across multiple sites, institutions, or geographies, accessible by multiple people. You see? It allows transactions to have public witnesses, so everyone is kind of this third party who can confirm that this happened, and the participant at each node of the network can access the recording shared across the network and can own an identical copy of it. So you see the basic idea that instead of having trusted third party, we make this data in some sense public. So it's not 100% public, because you can always introduce kind of some cryptography to make some fields not accessible. But in general, all the transactions are publicly visible, and everyone can see it, and everyone can kind of confirm that happens. That's basically the idea of blockchain. And probably everyone already heard about Bitcoin mining. So when people hear this example, usually immediate question is, okay, why then mining? Because what you said me could be just easily implemented without any mining. You just, okay, the idea of distributed databases are not new, but why mining? So the answer is, again, quite simple, but okay, you are right. The idea is simple, and if you try to search the literature, you realize that there are already some papers like 40 years ago about the idea of electronic money. So it's true that the idea itself is quite straightforward, but there are some, again, technical problems. And one of them is how to motivate people to keep the computers turned on. Because, like I said, everything works fine when everyone has its own copy of the ledger, and then you don't have any problem with consensus, because everyone has this copy. But what will happen if, for example, most of the people just turn off the computer? Then, for example, Bob is the only one who keeps his computer on. Then he just introduces a couple of new lines, like, okay, he got like $1,000 from someone, and he's the owner of the information, of the data, and he was the only one who decides what really happened, what not. So you see, there are some risks. So you need somehow to motivate people to keep this database running. This is one reason. And okay, this idea was solved exactly by mining algorithm, because people who keep this program running, the more resource they contribute to the system, the more computational power, the bigger chances they get of getting this new Bitcoin. So they're really paid for keeping this infrastructure on. This is one reason. And second reason why I need Bitcoin is what I mentioned, is the problem of consensus. So surely you will get to the situation when some conflicts will appear, right? Bob says we'll have this, and Ali says we have this information. So we need some algorithm which will establish consensus between the nodes without appealing to the third party. And that's another kind of smart and tricky solution, which was suggested by mining algorithm, which solves this problem of consensus. So to summarize, Bitcoin allows you to have the system running and to validate and confirm the transactions. And another reason, it prevents double spending and all these conflicts in consensus by establishing consensus in the system about the transactions. So that's basically the idea of Bitcoin. Definitely, you can find a lot of literature on this, but I tried just to make it more brief and simple. So that was the first part of my lecture. Again, just let me repeat myself. So this is just an overview course. I try to be as simple as possible just to give you an idea. Definitely, the technology is quite advanced, and I recommend you to read the papers by the guys who established this field. Satoshi Nakamoto, a paper about Bitcoin is really nice written. It's rather short, like 8 pages. And another paper by Vitalik Buterin and colleagues about Ethereum. So just do it. But basically, the ideas are very simple and straightforward, like I already described before. So now let's turn to the second section of my lecture. What is the idea of smart contract? So basically, okay, here are, I like formal definitions, but if you try to search for a formal definition, you realize that there are quite many of them. And here are listed just 4, which I like the most. So, okay, the first definition says that the smart contract is just a code and data that runs on Ethereum blockchain. And okay, this is clearly definition written by an engineer who doesn't care about use case or whatever. But again, this is a correct definition. So smart contract is just another piece of code which runs on very specific database infrastructure. Period. Okay. Yes, second definition is also more technical. Smart contracts are programs stored on the blockchain that run whenever predetermined conditions are met. You see, the difference to one is that implicitly it's rather clear that these programs are autonomous. So once something happens, some preconditions are met, then this program kind of rises and does something and then goes to sleep again. So it's not just a piece of code. This is this piece of code which behaves kind of autonomously. So independently, no one has to push the button to start it. So it starts automatically once the conditions are met. Okay, let's see the third definition, and it's probably the one which was written more by users than one technical guy. So it says that a smart contract is an agreement between two people, but in general it could be two or more, it could be 3 or 5, no restrictions. But okay, let it be. So agreement between two people in the form of computer code. So you probably have seen some contracts in your life when you go to a job or buy something expensive, whatever. So usually it's presented in the form of a document, which is written in some human language, and every human language is usually incomplete, is not clear semantics, and sometimes vague. Sometimes you can interpret some sentence in one way or the other way. So from this point of view, smart contract is just advanced version of a usual contract. So you have some conditions, some obligations, but everything in this contract is not written in human readable text, but it's written in a formal computer language. And then the transactions are processed automatically without a third party. That's already I told you. Okay, and let's see the first definition. A smart contract is a self-executing contract. You see, they stress the idea of autonomy, with the terms of the agreement between buyer and seller being directly written into lines of code. So this is quite similar. But you see, so as for me, this four definitions just provide you the more kind of the bigger picture of what smart contract is. That from one point of view, it's just piece of code, but it's just a usual document which many people use in their life, but just advanced version of this document, which has some obligations, agreement, whatever, etc. Okay, this is the definition of smart contract, and let's see some examples. So that's probably the situation familiar for everyone. So once you travel to another country, to another region, you will have to exchange money. Okay, now when you use credit cards, you don't really need to exchange money, but still like a couple of years ago, and for many countries even now, you come with one currency and you need to switch it to another currency. So the operation is quite straightforward. It's written on the right? So you have Bob Ellis, and it's quite symmetric. So Bob sends some amount of currency and some expected exchange rate. And Ellis has similar, in some sense, amount in different currency and kind of preferable exchange rate. And if they both agree on some exchange rate which is okay for both of them, they just exchange the amounts. And typically, this service is done by different banks or some exchange service. So usually you need to pay some additional fee to the person in the middle who provides you this service. Okay, this is just surely I simplify the situation, but in general, this is very close to the reality. So, but what you see there, it's what you're speaking here, that it's kind of an agreement. So see the definition number 3 with two people, and it's quite easy to formalize this agreement in the form of a computer code, right? Because nothing complicated happens here. So you just exchange the values, right? And okay, some third party gets some fee. So the idea is just in the air, why cannot we do it automatically and replace this third party serviceman with just a robot? And okay, this is just nice example of smart contract. So this robot is called a smart contract for P2P exchange. This is just a simple example. Okay, let's see another example. It's called lottery. So what's lottery? You have Alice, Bob, Carol, and maybe some other participants he purchased some tickets, right? And then, so in fact, they send the money to this organizer. And then after some randomized procedure, the organizers decide who is the winner and then send all the money to this winner, right? So Alice, Bob, and Carol send money to this third party, to the organizer. Then, according to this scheme, organizer decided that Alice is the winner. So all the money, let's say, okay, with some probably fee reduced, are sent to Alice. Again, it's just typical contract which you can find like everywhere, and there is nothing which prevents us from making it really formal to describe it in a form of just computer program, because what you need just to check some properties, then to run some algorithm, and then again perform some actions, just reduce money here, add money there. So the smart contract just compute the winner using probably a fair random generator, and then the winner receives all the money. So again, the idea is here that we replace this human who is organizer, okay, human organization who organizes this lottery with the robot, and this robot is called smart contract. Smart because it has some some logic, some programming languages, some computing power inside. That's why it's called smart contract. So, but actually, smart contract is just a robotic version of an organizer of the lottery. Okay, so guys, you can ask questions. I hope I'll see them and we'll try to answer. And also we scheduled a question and answer session for this particular lecture for Tuesday. So just feel free to ask me question in written form or whichever. Okay, let's consider a couple more examples which are very popular in the world of blockchain. And this is about voting. Again, what's voting? You have people like Alice, Bob, Carol, and other guys, and then you have usually one or sometimes two or more questions which you need just to collect opinions, right, about. And usually you have some kind of third party, the organizer of the voting. Usually it's trusted someone whom everyone trusts, who collects all these votes, computes the results, and informs everyone about the final results, trying to keep privacy so that no one knows who really voted for. And again, the procedure is quite simple, and almost everyone who knows programming can write it in the form of just piece of code on actually any programming language. So why cannot we replace this organizer of vote with just some robot who will do exactly the same? Just collect some information, check um, some constraints, then compute the results, and then inform everyone. So this is just very popular. From truly in real life, you can have a different specific like configuration for each voting. Like, okay, this guy has more votes. For example, if you speak about votes in some company, then different members of the board may have kind of different shares. So it's not that straightforward sometimes, but anyway, in any case, it always can be written as a computer program. So why not replace this organized with the robot? And this robot is called smart contract for vote. And another example, which is again quite popular in this field, is about investment. So typically, okay, for people, not everyone, but many people, some have some spared money which they want to invest for the future. For example, okay, when my daughter gets married, I will need probably some money for the wedding. So now I decided just to invest something. And usually, how it happens, I find a professional guy who say, okay, I know you should definitely invest into these stocks or these bonds or maybe another way, do this kind of. So you have someone, and then you establish contract with this person, right? And this contract is organized the following way. So first you send your money to this person, right? Person or organization doesn't matter. So to this body, so that this guy then suggests some ideas how to invest, right? Okay, usually he or she asks you for some parameters. Do you prefer risky investment or more conservative one? If it's a risk, then there'd be bigger chance that you will lose everything. But on the other hand, if you win, then you will high. So if it's conservative, then you will be sure that your money will be saved and you will have even some maybe increase. So this person asks you about your preferences, and then there are usually the answer is rather straightforward. So okay, if you look into the stock market, definitely there are kind of thousands of different options to invest. But most people, they usually invest in some kind of 1 to 3 ways. Either you invest in some index or in some industry or whatever. So, and at this level, each of investors usually knows what he or she wants. So you can always implement this communication as a software code. So you ask some questions from Alice, you get these answers. So you form this configuration for investment, and then you buy some asset which you expect to raise in price or whatever. So the idea that in quite many cases you can do it automatically. You don't need anyone. I mean, you don't need a human for that. It could be done by a robot, and this robot is called smart contract. And this is the idea. So you send the money to this contract. Contract decides with you the configuration, then invest the money, and then you get the investment back with some updates after the defined period of time. And okay, let me now focus on the third item, because we always had it. You see, each time you had the last item, it's gas for the contract. So indeed, in real life, each time you use some service, you need to pay fee to the organization or person who works for you. The same here, but the principal difference is the level of price. So here, fee goes to the miners who support this infrastructure, and usually it's quite small amount of money. But if you, for example, try to hire a professional financial expert, that will probably cost you like levels of magnitude more. So basically, the structure is the same. You have money to invest, you have this configuration, and you have separately pay the fee. But surely the fee is much smaller than in real life. Okay, and advanced version of previous example is a collective investment, which combines this example, simple investing, and that one. So if you have just kind of a voting system, by combining voting system and investment contract, you can design kind of a fund which is run by some people who invest money. Then some voting procedure decides where to invest the money. Then people just invest and get the returns from this contract. So you see, we start from very simple examples, but once you go into this field deeper and deeper, the ideas come just from the air, and you have idea, okay, let's do this and that and etc. So actually, almost, okay, let's not see it, but almost everything in finance could be done by some smart, simple or advanced smart contracts. And let's switch to one of the most known examples of smart contracts, which is called ICO. that's very similar to IPO. It's called initial coin offering, and idea is well described on this scheme below. So you see that basically the idea is to raise some money. So you have some company, some project, some idea which you would like uh, to find budget for it. So you issue some tokens. So just okay, it's very similar to stocks on stock market. So just papers with some written obligation, but in this case they are kind of electronic papers. So you sell these tokens to contributors and get the money for your project. So, and since everything is implemented on this electronic infrastructure, this is very simple to organize, very cheap, very kind of easily available. So anyone can launch a ICO, and okay, some consider it a feature, for other people it's a bug, but actually ICOs are unregulated. So if you are thinking about investment, you must be very cautious and diligent. And right, what I said, the ICOs are similar to initial public offering on stock exchange, but yes, with some probably maybe nuances. Okay, we'll speak about later. So how it works? The idea is that you, in fact, by starting an ICO, you design, you create your own currency. Because actually, the tokens we mentioned here are kind of new kind of currency. So, for example, you are Bob or you are Alice, and you say, okay, why can't I create my own currency? And the only thing you need for this currency to run, this ledger, this table, which keeps track of all the transactions. So, and you see, this is already implemented. So the infrastructure is already here. So you just create this table. And then once each time people exchange your tokens, you just update this table. You don't need any central bank. You don't need any centralized authority. So it's over the blockchain. So it's exactly what is spoke during the first section of my lecture. And right, so the smart contract for ICO is very simple. So participants send currency. If you speak about Ethereum platform, they send Ethereum Ether to the smart contract, and they get back this ICO tokens. So finally, the guy who organized this ICO gets a lot of money, and people get some 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 something strange. Okay, this is not even piece of paper, so this is they call tokens, and so what they get is just that the table, the ledger I showed you mentions that Alice has this amount of tokens, Bob has this amount of tokens, and then the ecosystem of this ICO goes on, and you may have like two different options. Either everything just stops finally, and then your tokens are kind of the price of token is zero, and everyone forgets about the tokens, and you will have to forget about your money. But there are still some projects are quite successful, and you can get a lot of return on your investment. So it may happen you bought this token for $1 and now it costs 10 or more. So, but you see, technically it's very simple to organize. That's why people like ICO. That's why people like smart contracts and Ethereum. And right, two more slides about tokens. So actually, there are two different types of tokens. One of them are called fungible tokens. Okay, for professionals, I mentioned that it's they are conform to ERC20 standard, and the idea that in quite many situations tokens are indistinguishable, right? So, for example, we have like a bill of $20, and okay, you ask me, give me $20 for lunch, and I give you $20, or I give you two bills with $10, or I can give you like four bills with $5, and for you it doesn't matter because you need to go to buy lunch, right? And lunch, the price of lunch is, for example, $20. So if you pay currency, each dollar is in some sense the same, right? That's why they call it fungible. Similarly, voting. For example, we have three people, and I ask each of you to write your opinion on a piece of paper and give to me, and then I count, and then one of you gave me yellow paper with something written with blue pen, and another one just gave me like a white piece of paper which is bigger and written with some marker, etc. So actually the information could be in many different forms, like $5 bills or $10 bills, but actually the only thing I care about is how many votes are for this option and how many are for the other one. So in this sense, tokens, your tokens, your votes are kind of the same. So if I'm trying to implement this kind of token, I would rather use this ERC20 standard, which is used for fungible tokens. Okay, and this is exactly how this standard interface looks like. Okay, sorry for maybe too much technical details, but if you try to go line by line, you will see that no surprise at all. So for every token, you need to define name, like US dollars or whatever, then symbol. This is typical for finance. Every currency has this like 3-symbol abbreviation. Then define some other parameters, like you need for every member to define balance, to some approval procedure and event, and two kind of events which are transfer and approval. So, okay, I don't have in plans to go deeply in this description, but you see that nothing really difficult. So just spend maybe a couple of hours, and you will see that this is more or less straightforward and clear standard. So, and the other type of tokens are so-called non-fungible tokens. They represent a situation when each token is unique. And the most typical example you see on the right corner, it's a movie ticket. So unlike dollars, tickets are all unique because each, besides the date, timestamp, and price, which would be like the same for all tickets for this particular movie, each ticket has also seat number, right, and row number and screen number, which makes it unique. So when you buy a ticket, you don't just say, okay, give me just one ticket. So usually ask, okay, which line do you prefer? Which seat do you like? Do you like these two tickets together, etc., etc.? So each ticket is unique, and there are quite many situations when you need kind of unique token for every asset, and some of them are written here. The first example is physical property, like houses. For example, you issue tokens which will be used to store information about some artwork, about houses, and clearly every house is unique because it has different location, different configuration. Some of them are old, some of them are brand new, etc., etc. So that's why you will need a separate token for every asset, right? And the same is about collectible cards and some unique pieces of art, etc., etc. So all NFTs are distinguishable, and once you try to program this smart contract, you will have to track the ownership of each of these NFTs separately. That's basically the difference to this ERC20. Okay, since many people try to apply this, finally there is a standard. for this, and it's quite similar to the previous one, but it's extended with this clear functionality. That's basically the end of this section. Again, questions, comments are welcome. And we go ahead with the next section, which is called Decentralized Autonomous Organization. So, right, the idea of previous slides was that in some quite widely used cases, we can replace a human or an organization with just a robot, right? The one who will run vote for you, the one who will provide exchange service, etc. But then, after you just get used to this idea, you usually make next step and think about why can't you make the whole organization run by robots? And here the idea of algocracy appears. So basically the philosophy behind this autonomous organization is that everything, every regulation and law informants could be implemented just with the computer algorithm. So we don't need bureaucrats and government and top management anymore, because we can delegate everything to just piece of software. And from the first glance, probably this sounds like okay, strange or maybe too sci-fi, okay, science fiction. But you see this picture on the right, so there's a picture of traffic lights. Think about traffic. And if you are driving a car in the traffic, who decides when to stop and when to go? So you rely on this traffic light system. So once it's red, you stop. Once it's green, you go. And you know, this is kind of really enforced. So if you disobey, you will be fined and maybe, okay, you'll get in problems. So you follow the rules, but actually there is no human in the middle, right? So the system is completely automated. So it's run by algorithm. And if it's configured and implemented without bugs and with good quality, everyone is happy to obey the system. Okay, almost everyone. So why cannot we do the same for not only for traffic, but also for some other applications? And that's basically the idea of this decentralized autonomous organization, that indeed all regulations, all law enforcement could be, all governments could be done by algorithm. So this is the kind of a basic definition. So like I mentioned, so it's an organization with no centralized leadership. So everyone is a participant, but you don't need to appoint anyone which is kind of higher than the other guys, right? So you don't need no leadership, because everything is run by smart contract. This contract defines the rules, and this contract holds all the money, and this contract runs all the procedures once you need some decisions, some voting, whatever. So, and all votes are computed automatically. And once the result is computed, the money are invested or sent exactly according to the algorithm. So this is basically the idea. And here are some examples. First example, charity, right? So charity works like, okay, like I already mentioned, it's very similar to group investment. The only difference is that you don't expect return on your investment. You expect that your money will be used in most kind of useful for the humankind way. So, and in charity, quite many people are kind of minor investors. So they contribute just small amount of money, and usually they don't have the own right or influence on how this organization will spend the money. So the idea is to implement this procedure with a smart contract so that everyone will see what's going on, everyone will participate in kind of a very simple procedure, everything is clear, everything is open. So this is basically the idea of charity example. Similar situation is freelancer network. You have network of people, and each of you works independently for different project. But for example, you need some to buy some office space. Okay, none of you alone is not rich enough to buy his her own office building. But if you have a group like 100 freelancers, it's okay for you. It's easy for you just to contribute some money and then rent this space. But again, in usual situation, you will probably need someone in the kind of who will be the manager or kind of the coordinator of this process, and no one would like to be. And for example, some person would like, but no one trusts him because you don't know each other. So it's really not easy to organize this process if you don't have this trust. But it's much easier to show everyone the open source code of an algorithm and to say, okay, this is how our organization runs, and you can just join our organization, and you will see that all the processes, all the business processes will be open. Everyone will have a copy of all transactions. Like I showed you, this table is replicated all over network, so you can trust the algorithm, and that's much easier. And similarly, the investment, this example already discussed. And this is just final slide of this section, that the idea of DAO perfectly matches the idea of ICO. So DAO is an organization which is run by some algorithm, but sometimes you will need maybe some investment for your organization to start the business, and you can raise this money with ICO. So you see, the whole infrastructure is kind of supports one part supports another one. So that's why many people believe in this technology. It will really change the world, at least the world of finance. Okay, and now the final section of our lecture today. We'll speak about Solidity. And Solidity is just a computer language which is designed by Ethereum platform, and it's each time you start to study, to learn new computer language or new technology or new framework, it's really very important to understand the main use cases, the main focus of application. For example, if you need to code something on a chip, then the first choice is probably C for your C++, right? If you are doing some enterprise software, then definitely it's Java or C#, right? And similarly, if you're doing data science, then mostly because of its libraries, Python is the leader. And similarly here, so Solidity is not, although it's kind of, all these languages are Turing complete, so you can do everything on any language. That's true. But for specific applications, the specific language is much more simpler, is much more convenient, is much more suited to use. So Solidity is the language which was created to work with this kind of examples I told you, with this finance, with transactions, etc. So it is high-level language for object-oriented and influenced by C++, Python, and JavaScript. It looks, I'll show you, very much like JavaScript or C++. It's statically typed and supports different features. So, but you should understand that it's really best for use for transactions. But okay, so here is a simplest probably example. And okay, if you remove the first line, you would hardly distinguish it from JavaScript, probably, or Java. or whatever. But okay, let's see what's about. So first we start with some instruction for compiler. In this case, you just indicate which version to use. Then we have declaration section, which is quite simple. I assume you introduce variable stored data, which is clearly integer here, and then you introduce two functions which will modify your values, right? So function set, function get, and then with modifiers like public, returns, etc. So this is a quite simple syntax. And what's important to understand that Solidity smart contracts is mostly about transactions. And to speak more formally, blockchain is just a transactional distributed database. And yes, since everyone has a replica, everyone can read entries. And once you need to change something, usually change means change the amount of money on different accounts, right? So to deduce something from one account to add to another one. So once you need to do this, you need to create a transaction which will be accepted by all the participants of the network. And this is done by sending a message which includes all the necessary information. And for those who are not familiar with transactional databases, this very simple slides to explain why we really need transactions here. So the idea is that in ordinary programming language like C, Java, if you don't speak, you usually think in terms of values of variables. Like you have this value, then you change it, you have this state, another state, etc. But in finance, this is the typical situation. You have two accounts, like account one, account two, and you need to move some amount from one account to another one. And then you clearly write these two lines in your code, but you need to always understand that you never run it in a perfect environment. So typically it may happen that, system crashes or network is not available or something else happens. And what happens if the first line is executed and the second is not? Because for kind of ordinary programming language, it's quite usual situation, because you may get some exception or some interruption, whatever. So if first line is executed and the second is not, then you deduce some amount of sum from your one account, so money is sent, but they are not received, and that's the problem. So transaction is situation when you need both entries pass or both entries fail. So this set of statements is called transaction. This is basically the idea. So because every part of it doesn't make sense. So either you accept everything, either you deny everything. So this is basically the idea of transactional databases, which is very, very usual for financial industry. And like I mentioned, Solidity is exactly targeted on such transactional databases. So the last thing to understand is that, like I mentioned, the smart contract is in fact a robot who simulates a human organization, and this is what exactly implemented in Ethereum. So in Ethereum, there are two kinds of accounts. First kind is called external accounts, which are accounts which are run by humans. So you can just log in and initiate some transaction. For example, send some money to your family members, whatever. And the second kind of accounts are called contract accounts, which are actually accounts which are run by robots, by smart contracts. But what's important from the point of view of Ethereum, they are exactly the same, because the virtual machine doesn't care who initiated the transaction and why. So if you recall my initial picture about this example, then you have Bob, Carol, David, and different other participants sending money to each other. Actually, the picture looks like that. So you have some participants of the network are humans, and the other participants are robots or smart contracts. And humans behave on their own, and contracts behave according to the code which is written in Solidity language. Basically, this is the all. Yes, and I already mentioned the notion of Ethereum virtual machine. It's the name for runtime environment which runs this this whole infrastructure. And this is the final slide of my lecture today. I took it from a very nice paper by guys from Microsoft mostly and other co-authors. The link is here. But let's go through the scheme. So the blue cloud here is a blockchain ledger. So the circles are nodes, and like I mentioned already, each node has a copy of the following information. So the address of installed program, balances of all addresses, I mean balances in terms of money, how much money every account, every address has, and also state of programs. So this information is kept through the network. To run a smart contract, you first, so it's on the left, you first create it in code it in Solidity, then you compile it and install it into the system. And like I mentioned, smart contract is just another participant of this node, which is actually a robot. And okay, so some transactions are initiated by people, some by contracts, and to transfer money or tokens from one address to another one, you need to provide address, you need to provide this amount, and then you need to provide this fee and some maybe additional data, right? And here is yes, more detailed information about mining. The guys who really run the infrastructure and are paid, are motivated by this gas for the mining. They sign all the transactions so that the consensus is established in the network. Okay, so here are just a couple of links for more detailed information. I really like this YouTube video, which really goes step by step with running example on Solidity. And also I recommend this text tutorials from Tutorial Point and 101 blockchains. And definitely there are much more information on the web because the topic is kind of hot topic and everyone is interested. So a lot of different useful resources on the web. And okay, for those who are interested just to check yourself, to maybe refresh information of our lecture, I suggest the homework, which consists of several questions in Google form of theory test. And I suggest you to write this, our first example of P2P exchange, just to implement smart contract of this kind in Solidity, and then just put the code on your GitHub account and paste the link into the form. The link is provided. So, okay, definitely it's not necessary, but surely it's a useful exercise. And again, let me announce that next Monday we will have a question and answer session for the first lecture, and we will speak about the questions and about homework. And Tuesday, 12th, is scheduled for this date. Is scheduled question and answer session for this lecture, and we'll discuss maybe some slides which are not that clear, and we'll discuss the homework and the questions. So thank you, everyone. I see some questions, but okay, I suggest we'll discuss it on Tuesday because we already 1 hour here. So Thank you everyone for joining. Hope see you next time. Bye bye.